It's been far too long since I did a video about video. Let's fix that. For reasons I have never understood, I'm fascinated with television production gear, and I have a tremendous collection of it, but much of that stuff has never shown up on my channel, and that's partly because a lot of it does pretty much the same things as all the rest. Like my entire rack of huge studio cameras. They all make nearly identical pictures, so there's not really much to discuss there. I don't know what to do with it all. But there are some unusual things in my collection that are worth showing to you. The problem is there's a bunch of work that I have to front load first. For example, look at all this crap. This is my video mixer collection, or most of it anyway. I left two of my TriCasters at home, but I've got this one, and I also have a bunch of 80s and 90s Panasonic mixers. There's this crappy one from Data Video. I've got an Amiga video toaster. I have several non-Amiga video toasters. I've got this bizarre PC-based thing from Sony, and there's a couple others around here somewhere, and all of this has just been piling up for years, and I don't need any of it. I'm gonna turn this off. These fans are so loud, oh my God. The only reason I have any of this junk is because everything here has some weird quirk that I wanted to show you, but well, before I can explain how weird it is that the Data Video SE500 has a MIDI port on it, you need to know what's supposed to be on the back of one of these. And I imagine that most people watching this don't know the answer to that, because there's no reason you should. These are all various takes on the same tool, and it's one that no consumer has needed for almost 25 years at this point, and even before that, almost nobody had one. It's mostly an industrial tool, but you know me, that's my thing. My interests tend towards television, but I'm intrigued by how almost any sausage is made. For instance, I'm currently working with a viewer to help get a hold of an ancient broadcast automation system from a radio station. As in, the thing that ran the music playlists, but in like 1993. I don't care about radio. I don't listen to it. I don't want to work in a radio station, but a chance to see part of how that job was done and to learn about equipment that you'll never find in a magazine and hardly find on eBay and won't find any special little fan websites about fascinates me to no end. And I mean, look at this stuff. Even if you don't have any use for it, aren't you curious what this all does? I think I can safely assume that's a unifying element in my audience. So I'd like to explain the fundamentals behind these things so that I can show these to you in the future without having to go through the whole explanation from the ground up every time. And to that end, I just want to pick one device and thoroughly explain it. Except that's kind of complicated. I don't think it would surprise you if I said that explaining how this works would be too much for a casual video. I'd be putting you through trade school, essentially, and I doubt that's what you came here for. So I had this idea that I would take one of my simpler, more consumer-y switchers and just explain every feature on it, but that went poorly. I wrote a script around this guy here, the Data Video SE500, because it's the smallest, simplest device I had. Looks pretty digestible, right? But then I sat down to try to film it, and I found out that it's actually missing some features that make it useless for a demo. So I tried falling back to my first mixer I ever got, this Panasonic, and that turned out to be weird too, in ways I never realized. It turned out all my mixers were weird, because there were never really consumer applications for these, not really. So all the small and simple ones aren't truly representative because they're so heavily dumbed down. So I'm going to have to explain the basics on this. But don't worry, there really isn't that much to it. In fact, about 2/3 of this panel isn't even important right now, and we're going to ignore it. I'll explain it all someday. But for now, I should probably start by explaining what the hell any of these even do. A video mixer, also known as a video switcher or a vision mixer, is the television equivalent of an audio mixer. In the same way that one of those is at the heart of a recording studio, a video mixer is the heart of a TV studio. In any control room, you'll see a huge board with hundreds of illuminated buttons. It's very clearly the focal point of everything. That is this, just usually bigger. Video mixers do come in a bunch of sizes and prices because there are different sized TV studios and because they have applications outside of broadcasting. They get used in concerts, churches, big public presentations, basically any situation where you're seeing a live picture from one or more cameras. Now, at least That's what they're used for now. But for the first half century that video existed, up until the 2000s, mixers were needed for most commercial video editing, whether you were making a corporate training presentation or an advertisement or just dressing up someone's wedding footage. And I'll talk about all that in a future video. It's a whole topic. But it's even more moot than the rest of this video because for post-production, these were completely obsoleted by computer editing nearly 20 years ago and nothing of value was lost. The only relevance they have nowadays is for live production. And even then, in the last decade, PCs have displaced a lot of the hardware. But hardware mixers are still around and most of the same principles apply to those and even to the software versions. And they're principles that haven't really changed since TV was invented. Mixers were introduced in the earliest days of television to solve a fundamental problem. TV was shot on multiple cameras, and they needed a way to switch between them. With recorded video or film, you'd do that in post, but with live, there is no post. All the stuff that an editor would do with film strips back then, or MOV files in Adobe Premiere now, instead needed to happen with the raw signal coming out of the cameras second by second as the action unfolded, so they had to make devices for doing that.
During the broadcast. On the screen in the control room, we see a scene made by the close-up camera. After this has run for a few seconds, the control engineer switches over to the other camera, and the scene changes to a long shot of the entire orchestra. The director manipulates the cameras to keep the scene changing and to avoid monotony, instructing the cameramen and engineers by telephone as the program progresses.
All right, switch to one. Now roll into a close-up of the string section.
It didn't take long, though, for manufacturers to realize that they could dress up that essential need to make the switching process more visually interesting. And eventually they also realized that a switcher was a convenient place to add special effects.
Now, the Vision Mixer can do some very interesting things with the pictures that he has in front of him. By taking two cameras and two pictures and mixing them both together very slowly and gently. Watch.
So over time, these grew from simple selectors into fiendishly complex multi-effects units, like one of those guitar pedals that can do everything from reverb to pitch shifting. A high-end unit can superimpose images, can transform them, composite them, and it can even provide its own video sources internally, and all of this gets used heavily in modern television. Think about during a talk show. They flash people's names up on the screen, along with whatever makes them significant. And when you're watching the news, they put a little box next to the anchor with a picture in it, or they put two anchors in their own little boxes. Or when you're watching a football game, sometimes a football flies across the screen and suddenly you're looking at a player interview. All these extra flares are added inside the mixer. So these end up being very expensive devices. Supposedly, if what I found online was true, my Ecolab here was originally about $45,000. But a Sony unit that ESPN might use today costs well over $100,000. Even the little dinky one that I almost used for this video cost $900 new, and those market divisions are largely about the variety and quantity of special effects. The Ecolab could do all the stuff I just mentioned. It needs help from external gear with some of it, but it can do it. A modern high-end production switcher can do all of that and more with no help at all, and the Data Video can't do any of it. And that's part of what makes it hard to talk about these things. It's like describing what a PC can do. They can do a lot, and what kind of PC, how expensive, from when. So I'm going to stick to the absolute bare essentials, the stuff that's been in literally everything for decades, and that's switching and basic mixing. Now, the first part, the switching, that's easy. You probably owned a video switcher at some point yourself. One of these that sat between your GameCube, your PS2, and your TV. You plugged them all in back here, and then you could pick which one you were playing at the moment without having to get behind the set and move the cables around. You just press buttons. And inside, there's nothing more than 4 mechanical switches. All this does is automate the process of unplugging one cable and plugging in another, and these could be had for about $20 in 1993. But the other part, the mixing of 2 images, that's incredibly hard. See, mixing something like audio is easy. You take your 2 signals and you mix them, literally. If you just want to combine the output from 2 tape players, you can just twist the wires together. A resistor between the 2 will make it a little healthier, but overall, it's just a non-event. And if you want to pan sound, change the volume, equalize it, whatever, you can do all that with some real simple analog components. And that's why you can get a 4-channel mixer with EQ for like $40. But the reason that's so easy is that audio is one-dimensional. 2 if you count time, although we usually imply that part. But the only variable in sound is amplitude that continuously changes over time. If you mix one amplitude with another, you get the combination of the two. And our brains are designed to understand that, so bam, you're done. Video, on the other hand, well, it has 2 dimensions and thousands of variables. Every pixel on your screen is like a separate amplitude. It's like a channel of audio in itself. If we sent all the parts of a TV image as continuous signals, even a standard def picture would require as much gear as 350,000 channels of audio. Or actually more, because every pixel has 3 components, red, green, and blue. A modern 1080p picture sent continuously, like audio, would require 6 million separate wires. So we don't do that. Instead, we quantize it. We take a snapshot every 60th of a second, or every 50th if you're in the EU, the metric system, and we send that 1 bit at a time, column by column, row by row. All video, even the analog stuff that doesn't have discrete pixels, is still essentially serial. You can't make any sense of it unless you spend a whole 60th of a second accumulating data and reassembling it. And what we manipulate in video is also far more specific. Doing a split screen effect is the equivalent of precisely cutting one person out of a recording and replacing them with another, which didn't even become possible for over a century, and it's still incredibly uncommon. If you want to join 2 pictures down the middle, the mixer has to know exactly which row and column is being drawn at every moment so it can stitch the inputs together over and over on every frame without lining them up wrong. So yeah, these things have to be complicated, but that's funny because an awful lot of the time using them isn't. Let me demonstrate. Our sample mixer today is the Ecolab Overture 2, or maybe Opera 2, or maybe Identity 4, not really sure, the branding is kind of confusing. This is the highest end mixer I have, but it's also the smallest production mixer I've really seen, which isn't saying much given this is the size of a car dashboard, and that this isn't even actually the mixer itself. Let's see if we turn this around. There's no video inputs on the back. There's just these 2 ports on the side labeled TX and RX. This is how pretty much all mixers are built. This is called the, control surface, something like that. And then the actual mixer goes in another room in a rack. Now, the reason for that is that these usually have pretty loud fans, and this one's no exception. I actually will be putting this in another room for the duration of this video because it's so loud that I'm shouting over it. But the other reason is cable management. This is a fairly modest unit. They get a lot bigger, but this still has nearly 100 connections on the back, all of which might get used at once, because it supports as many as 16 inputs and outputs with as many as 4 cables for each, because it's either composite component, YC, or SDI digital, or all of the above. Now, to give you an idea what that cabling looks like, someone who works in a TV station sent me some of their spares when they did HD upgrades, and they looked like this. These are bundled together, to be fair, but it's still just a lot. You don't want all this snarled up under your workstation. And since we're talking analog here in a lot of cases, you also want these cables, both from the cameras to the mixer and from the mixer to other equipment, to be as short as possible. So you want to put all your processing gear right next to each other in a rack in another room where their fans can be as loud as they want. Run all your cables there, and then run just 2 little control cables to wherever you want the control surface. So we're gonna hook up our ins and outs and then get rid of this thing. Now the inputs are simple. They're just labeled 1, 2, 3, 4, etc. And you hook those up to every source that you might need in your program. Cameras, VCRs, computer graphics generators, and so on. I'm gonna have a couple cameras hooked up in here and then probably a TriCaster playing some video in case I want that. And then we've got the outputs, of which I think this has about 8, and you can use those for all sorts of purposes, but the 2 standard ones are the preview, which is going to hook up to a monitor on my desk so I can see what I'm doing, and then program, which is where we get our program, the finished product. Besides that, there's just 2 more cables up here that are going to connect to our control surface, and now we can hurl this machine into the sun.
2 hours later.
I just spent 2 hours wiring everything up and tucking it all away, but I'm finally ready to switch on the console. And it's worth it because it's kind of breathtaking. If you're concerned about not getting to see what all these controls do in this video, don't worry, I've been planning a deep dive on this specific machine for years, just because this user interface is incredible. The Opera uses every imaginable form of input and output that existed when it came out in 2006. It's got VFD, it's got LCD, it's got LED displays, multicolor illuminated buttons, levers, knobs, encoders, a joystick, a numpad. It's all here, and it's worth a whole video, which it will get eventually. But for now, prepare yourself. You're about to see how television is made. Here we go. If you need a drink of water or something, you can just pause. I won't mind. Wouldn't want you to get overly excited. All right, I'm joshing, but also not really. It's disclaimer time. I've never worked in a TV studio or run a live show. The only one I've ever worked on was my own last year. If we can jump over, if we can get a picture on the screen here.
So this is going to be the next thing, is figuring out how to power
I'm sorry,
this.
just a moment. Can we actually trim the camera up a little bit so we can, there we
I think
go.
there's a beer in there for scale.
And it was actually my girlfriend who ran the mixer, so technically I have zero experience doing this for real. But I've spoken to people who have, I've read about it, I've watched videos, and I feel pretty safe with the claims I'm going to make. So here's one. Most of television production is that one action. The person who sits at the video mixer, who's known as a technical director or TD, spends most of their time just choosing the camera that has the best angle on the action, whatever that might be. Suppose we were doing a talk show, for instance. You'd have cameras pointing at the guests, at the host, one at the overall stage, maybe a couple others pointing back at the audience. And as the show progresses, when the host is talking, you usually see them. And when the guests are talking, they're usually on camera. And when the current speaker changes, you see the picture pop from one angle to the other. That's called a cut, and it makes up most of TV. If you're watching the news, when they switch from one anchor to another, it just pops between cameras. And if you're watching a basketball replay, the camera will just pop to whoever has the ball at the moment. And to do that on this switcher, you can just press these buttons. See right there on your screen? That should be the program feed. That's the output on the back of the switcher that goes to the transmitter. It's our finished TV show. So we're on camera 1 right now, camera 1, and now we're on camera 2. Hi there. That simple act of cutting is all this top row does, and it sounds like you could just do this with your GameCube switch box. And, you know, that's not all that far off. Inside that big rack unit that I showed you earlier is a bunch of expensive digital processing circuitry. It's not very easy to see, and it's nothing to look at. It's just some meaningless chips. But there's also a little bank of relays. And those are impossible to show you, but when I pick a camera, you sure can hear them. That was the mixer literally using switches to select a signal, just like the switch box. Some even cut that selected input straight through to the output. So it's literally doing what your $20 Radio Shack GameCube switch did. I don't know if this one does that, but you get the picture, pun intended. If all you're doing is switching cameras, all you need is a switch. And while there are reasons you couldn't really run a broadcast out of a little mechanical switch box, you also kind of could in a pinch, and a lot of viewers might not even notice it depending on what the program is. So if this is such an easy thing to do, why did the Ecolab cost $45,000 even as a mid-range offering? Well, 99% of a show might be switching cameras, but then there's the other 99%. So let's take a look at the panel and I'll explain how this is actually used. This row of buttons that I just used is called a bus. Every mixer has to have at least 2. This one has 3 and some have a dozen. The term once referred to the actual electrical layout inside, but nowadays it just means that all the buttons on each row represent the same set of inputs. These buttons, labeled input 1, 2, and 3, select those 3 inputs on the back of the device. All 3 buses select the same inputs. They just send them to different places. I'll explain where as we go. Notice that the inputs are labeled with LED screens, and that's partly because they're actually redefinable. Older mixers had little button caps you could just pull off and then write notes underneath, which is neat because if you look at these things on eBay, you can learn all sorts of interesting stuff about what gear people were using because they'll just write brand names on those caps. Like you'll see some that say Deco, which was a graphics generator from Avid. On newer machines, though, like this one, you can just set those labels in software. And in addition, there are more inputs here than there are buttons. You can press Shift and get a whole second page worth of them, including some that are internally generated. And I'm not going to get into all of that in this video, but for instance, if we hit Shift Color 1, we get a solid color. That's the internal matte generator. Almost every mixer has one. It just produces a solid screen of whatever color you like. There's also a button for a plain black screen, if you just want to show the viewer nothing. There's usually a button for color bars, and a lot of mixers have one or more frame buffers, which let you load up a single still image, like a title card, for instance. These are the main two buses on every mixer, and they have very specific purposes. The top one is called Program. Some mixers have other names for it, but it's usually called Program because whatever you pick here is generally what makes up 95% of your finished program. In theory, this bus could be your whole show. It controls the program output, and that could be going directly to a transmitter or a tape deck. Cameras come in, the mixer switches them, the result goes out to your audience or gets recorded, and that's a show. The reality is usually a bit more complicated. For one thing, the program feed usually goes through other equipment on the way out. For instance, a lot of TV stations have a dedicated box that just injects the station logo, so the mixer doesn't have to waste any resources on it. And there's also devices like the NBC Name Dropper, which are used to inject regional headlines over the top of a network news program, so viewers get a combination of local and national news all at once. There are also several features that can add additional layers of graphics inside the mixer, but most of the time, most of what shows up on a viewer's screen will be what's selected on the program bus. As the name suggests, it picks the primary subject of the program. The second bus on this mixer is called Preview, but on most it's called Preset. This bus doesn't change the program input. Instead, it chooses an input that you're thinking of changing to. So next makes sense, but what's this preview bit about? Well, it's actually very important. See, you can run a TV show like I just showed you. You can just hit the buttons on the program bus. But that practice is frowned on by a lot of people, and it even has its own somewhat derogatory term, hot punching. The technical director, as I understand it, is often the person actually choosing which camera is the best angle at every given moment. Sometimes there's a separate director role, but either way, someone has to be staring at all the possible cameras simultaneously and picking the most interesting angle for every moment. Now, in a studio control room, at least the ones I've seen, all your raw inputs are displayed on an array of little tiny monitors because you only have so much space and a lot of inputs. So if you're sitting at your console watching all of those and you just go, hey, camera 3 looks good, and punch it up on your main feed, that might be the moment when you realize that camera 3 is actually out of focus or that someone just started scratching their ass. Hot punching doesn't leave you any wiggle room. As soon as you hit that button, you're live. But on most mixers, the second bus, whatever it's called, appears on the second output, the preview. And the TD usually has a pair of larger monitors connected to both program and preview sitting right in front of them, like I do here. This one's preview, this one's program. When you pick an input on the second bus, your viewers won't see it. See, doing this, the program feed hasn't changed. But now I can get a proper look at it up close before I actually take that input live. That's the term, by the way, for switching program inputs, take. So you might preview camera 2 to get a good look at it, and then once you're sure you want that shot, you say take camera 2 and hit a button labeled take or sometimes cut, like this one is here. When you hit that, the two buses switch places. See, we've got camera 1 on the program, camera 2 on the preview, and when I hit cut, they swap back and forth, both here and on the outputs. Now notice, it swaps them. It doesn't just make camera 2 live, but now camera 1 is back on my preview display. So I'm ready to switch right back if I need to. That means if I was doing like a really intense interview, like no wide shots, just close-ups of the participants, the whole show might just be me picking two cameras and then hitting cut over and over at all the right moments. Not that hot punching is completely forbidden, though. For instance, in this interview with the Vision mixer producing the BBC's Strictly Come Dancing in 2011, it seems pretty clear that she doesn't even go near the cut button, just keeps her left hand on the program bus and goes for it.
Sort of hand Essentially, you cut with your left hand and you use your right hand for doing anything else like setting other bits of the desk.
And that makes a lot of sense. Given the rapid-fire nature of the show, there's no time to preview every shot, so she just goes with her gut. But if you're not doing a machine gun production like this, then taking the time to preview and cut really seems worth it. This, by the way, is why I couldn't use the Data Video Mixer for this video. It doesn't have a cut button, which makes no sense, and I wasted over a week of effort because of it. Anyway, when I joked earlier that TV mixing is just hitting these buttons, that wasn't far off. I mean, you aren't just hitting them straight on the program bus, but it's only one extra step to do it right, and it's functionally the same thing. From what I've been told, this really is what a lot of TDs spend most of their time doing. And that's the entire switching component of a mixer. That's all it does. Every other feature on here is some kind of special effect. This unit has some effects that others don't, and it lacks some effects that other ones have, but the one thing that's always there, even on my crappy Data Video Mixer, are basic animated transitions. For instance, on every mixer ever made, you'll find a button labeled Fade, Dissolve, or Mix, like this one here, and that switches inputs by just blending smoothly from one to the other. Now, I say this is universal, but I mean it. It really is. Even in the earliest days of TV, you could do this with a single variable resistor, so there was no reason not to include it. It was just free real estate. Nowadays, there's usually a variation available called a dip, like here. It's the same thing, except that it stops at a black screen or sometimes a solid color in the middle. Slightly more involved, but still universal, are the wipes. That's where a line sweeps across the screen and leaves a new picture behind it. This is also something you can do with fairly simple analog circuitry, so it's been standard since at least the 70s. Usually you can apply these in different directions. You can do horizontal, you can sometimes do like out from the center, and anything newer than the 80s can usually do feathered edges or borders to dress it up a little bit. So those are the universal ones. You'll find those transitions on everything going back at least 40 years, and that's because they're all very easy to implement in basic analog circuitry. There are thousands of other kinds of transitions, but they all require digital processing. It's easy to chop or to mix two analog video signals, but it's really hard to do something like squeeze an image or move it around because everything's happening in real time. Like I was saying earlier, TV signals aren't continuous. They're a series of discrete frames, and in the analog days, they were sent line by line. If you were doing a split screen effect, when the mixer was outputting the first line of its finished picture, it would display input 1 for half the horizontal travel, then switch to input 2 for the rest. That was easy. But if you wanted to move camera 2's picture up relative to camera 1, that was impossible. I mean, literally impossible. It could not be done. See, both cameras have to run in perfect lockstep for analog mixing to work, and that was accomplished through a technique called Genlock, a whole topic in itself that I'll cover another time. But in short, when the mixer's outputting the first line of a video frame, cameras 1 and 2 are both outputting their first lines. To move camera 2 up, the mixer would have to draw part of line 1 from camera 1, and then part of line 2 from camera 2. But at that point, line 2 hasn't been sent yet, and by the time it has, the mixer's already finished line 1 and moved on. It's too late to go back and change it. So for a mixer to move an image forward or back or side to side, let alone rotate it, it needs to capture the whole frame first, so it has all the information on hand at once to work with. And the only way to do that is by accumulating the whole picture into a frame buffer and then processing it in the digital domain. Any effect that works this way is called a DVE, or digital video effect. Imagine that. They were around at least by the early 80s, and up through the late 90s, they were still fantastically expensive, which is part of why consumer video mixers were never that much of a thing. By the time frame buffers and DSPs came down in price, consumers had started using iMovie, and it was only pros who still had the need for a hardware solution. Now, my guess is that by 2006, everything this mixer does is actually happening in the digital domain. I doubt it's doing a lick of analog work because the technology had just becomes so cheap by then. But the old terminology stuck around. Even on new mixers, which work solely with digital signals and aren't doing any of that real-time racing the beam nonsense, transitions are divided into fades, wipes, and then an enormous variety of effects that are all lumped in as DVEs. Most mixers made after the 80s have so many DVEs that they actually have you look them up in a booklet and punch them in on a numpad. The Ecolab's actually remarkably convenient because it lets you navigate with this little visual menu interface over here to pick whatever you want. But you can imagine why not every mixer would offer that. they really spared no expense, at least for 2006. DVEs all move or transform the image in some way. So you can push one image off the screen to reveal the next, or you can have it shrink off the screen, or you can have it swoosh off the screen, and so on. Now, I could sit here and demo every single transition all day long, but I'd rather address what feels like an elephant in the room to me. I'm always a little confused by why mixers have so many transitions because I feel like they aren't really used in most TV. I don't watch a lot of television, like hardly any at all, but I have watched it in the 90s and 2000s and now, and it seems like transitions are really rare. If you watch the news or a sports broadcast or even most local interest programming, almost every shot ends with a hard cut, even when they're switching subject matter. Sometimes you see dissolves, narrative programs often dip to black between scenes, and of course every show fades to black before a break. But the other stuff, the wipes and like curtain effects, and certainly the 3D transforms and shit that you find in every mixer now, where's all that getting used? I've always seen people in and outside the industry refer to animated transitions as corny, cheesy things. You know, the eternal joke about cheaply produced video is the star wipe.
Okay, from here we star wipe to a glamour shot of Flanders paying his bills.
Which, yeah, looks pretty silly to me, although ironically, most cheap mixers can't even do it. The only one I have that can is the Echo Lab. And it doesn't help any that outlandish transition effects are like flypaper to amateurs. If you were watching YouTube videos in 2007, you probably saw tons of DVEs from iMovie and Windows Movie Maker, like the page peel or the explosion. Hell, if you were uploading videos to YouTube back then, you probably used those. They seem to be in every single video for a decade, and that's probably condemned these effects to clownishness for eternity. The working TDs I've asked about this said they've almost never used even the simple transitions. 99% of the time, they just do cuts and the occasional fade. In fact, the manual for the data video, despite being the cheapest, corniest mixer I own, even says that if you watch TV, you'll pretty much just see hard cuts. But it doesn't go on to explain why, then, you would want these. So if I'm honest, wipes look silly to my eyes. And from the evidence, it feels like most TV producers agree. And yet they're on every mixer, even the really big expensive ones. So they're getting used for something, I just don't know what. To be fair, I do know they at least used to show up a lot on regional television.
This program airs statewide on California Public Television and is a California's Gold classic.
Hi, I'm Huell Hauser.
I'm literally using a clip from California's Gold. California's Gold. There's definitely some notable exceptions to this. One effect I think I've seen more often is the slide, which I think started showing up more often after the iPhone came out and a lot of people got used to seeing slides all the time. There's also what's called a graphic wipe, which is like a normal wipe but with an image floating over the cut line to hide the seam, like this. Whoosh. Just makes it a little cleaner, gives a little more flavor. Those used to show up in things a lot back in the 90s. But what's vastly more popular now is an enhanced version called a stinger. You know when you're watching like a basketball game and a ball or a Krispy Kreme logo bounces onto the screen and then disappears to reveal a new shot? That's a stinger. It sometimes covers up a normal wipe, just like the graphic wipe. But a lot of the time now, they just have the animation obscure the whole screen and then it just does a plain cut behind it. Now, these things are everywhere. Sports broadcasts use gobs of them, and sometimes they don't even really do that good a job. I keep looking up examples of stingers and noticing that they often just have like a football fly towards the screen and then vanish, and you can just see the cut happen. Like, what was the point of the stinger then? The news also uses the hell out of these things to change segments, to cut back from like a field reporter to the studio, and sometimes just to announce which town they're about to read the weather for. YouTubers also adore them. They plaster them everywhere, which has led to a massive market for stock effects, like this one, which I downloaded for free from a website that had thousands on offer. So stingers are tremendously popular, and they have been for about 25 years, maybe longer. But like I said, it feels like they're the only transitions anyone really uses on TV. But if that's true, then why are these basic wipes still here? Not just in 2006, but on brand new mixers made even now.
10 registers available for preset wipes. 1, 2, there we go.
Maybe I'm wrong. Maybe they're actually super popular. I'm just not paying attention. One angle I've considered, though, is that however useful they may be as transitions, they can also be used as live editing tools. And to explain that, I'll show you a couple other important controls. Once you've chosen a transition effect, you usually make it happen by hitting a button labeled auto, or sometimes auto trans, and that just performs it very smoothly at a preset speed. You can adjust that speed, you can make it much faster, or you can slow it way the hell down. I have to wait for this to finish so I can continue my script. I imagine newer mixers probably let you define custom motion curves and stuff. I don't know, I haven't used anything newer than 15 years ago, but basically you just hit the button and you let the mixer do the work. But you can also do them manually, and you do that with this thing here called the T-bar, for obvious reasons. There's one of these on most mixers, and it's obviously what everyone wants to play with as soon as they see the thing because it looks like the throttle on a jet. The T-bar is coupled directly to a transition, so you can perform it at whatever speed you like, fast or slow, or you can change speed gradually, or you can stop in the middle and reverse, or you can just stop completely. Now, I'm not really sure why you'd want to do most of those things in a real TV program. I've watched tutorials that show you how to use the T-bar this way, but they never suggest a reason to use it instead of just hitting auto. Trying to fade by hand during a broadcast sounds like a recipe for disaster. It seems like it would be impossible to keep it smooth and steady, and the TDs I've spocked to. Christ, where were we? The TDs I've talked to mostly agree. They mostly just use the auto button. But I've seen footage of them being used in broadcasts. So people do, I'm just not really sure what it gets you. One special thing you can do with this, though, on almost any mixer is to make a rudimentary split screen. If I had cameras pointing at two newscasters, for instance, I could put a vertical split right down the center, like this, by pulling the T-bar halfway and then just leaving it so they can both be on screen at once. Now that's a pretty neat trick, and it only takes like 1 second to set it up. I could also do a horizontal split, although that seems less useful, and I could like notch out the corner like this. Hello. Or I could do a diagonal wipe like that, like those little pop-up ads that come up over the show you're watching to tell you about an upcoming one. But besides tricks like that, I'm not really sure what the T-bar is for. I'm sure some TDs are going to take me to task in the comments and explain it. I fully invite them. I just think you have to actually do the job to understand what that thing's all about. But that's pretty much it for transitions. And the one other useful feature that seems to be universal, at least these days, are keyers. So I should talk about that. Now, that's a term from past years. We would just call them layers nowadays, since we're all software-minded now. But whatever they're called, they're extremely important. So far, everything I've done has just changed what's on the program bus. I've done it in some fancy ways, but everything that I pick just goes out unchanged once it's active. It's as if it was just being passed straight through the thing. I can mix in another video, but everything I do with these is a full screen effect of some kind. A keyer is useful for non-full screen effects and for actually properly layering video rather than just blending it. And keyers are, or at least were, a big price differentiator in the market. This Echo Lab has, I think, 6, maybe 8 keyers, so you can put 6 or 8 extra layers on the screen. But a modern high-end Sony one has, I think what I read was 40. And this is where this third bus finally comes in. Unlike the other two, which are fixed function and always do the same thing, the third one, the select bus, is context sensitive. It's used to pick inputs for various other functions and special effects, including the keyers. Now, the UI on these things is really confusing, so I'm going to gloss over most of it. But basically, I just select this guy here, pick camera 1, and then turn this on. And it looks for all the world like I just took camera 1 on the program bus. But watch this. I'm flying. Yeah, that's what this is called, flying a key. I can actually resize it, move it, or even rotate it however I like. And buried somewhere in the menus here are methods for doing a lot more than that. I think you can actually crop it, you can apply soft borders, among other things. But Perhaps most importantly, as the name suggests, I can key this source. Keying is the term for any mixing operation where you make some parts of an image transparent. The best known form is chroma key, which people normally just call green screen nowadays, but you can also luma key and linear key, and it's possible to cut one image using another, and these are all used for different purposes. Now, I cooked a chroma key before the show today, so if I hit CK here, there we go. I've already got that all set up. There's a whole bunch of knobs up here you have to rotate. It's really fiddly, like, see that? It gets really speckly back there if you don't know what you're doing, like I don't. But, you know, this is the weatherman thing. I could do the weather with this. I just have a computer generating a weather map. I'd plug that into input number 4, select that on the program bus, put myself on the keyer input like this, and here we are at the fountains. In 2006, I think it was still pretty cool to be able to do this right in your mixer, because a decade earlier, I know you had to have a whole separate expensive piece of equipment just for this one task. So obviously, keyers are really important. You know, you can do the weather, you can put an image up next to a newscaster, or put talking heads in boxes. It's how you add a program logo or a pop-up name tag, what they call a lower third graphic, to a program. And the actual contents of these keys can be anything, because they're usually fed from somewhere else. Certainly when this came out, they were still coming from boxes called CGs, or character generators, kind of a misleading name. It really describes basically just a PC with a special video card that generates or plays back graphics of any kind, not just text. Some mixers, including this one, can do a little bit of the CG work themselves, but I think even nowadays, there's still usually a dedicated machine doing the bulk of the effort. And with that, we're actually kind of done. Those were the core features that I wanted to show you. I drug it way out because that's what I do, but I could have shown you all that in just a few minutes. There's more here, to be sure, but those are all the things you need to know about for me to make future videos about these devices. And in fact, almost all those features were on the Data Video Mixer. I tried really hard to talk myself into using it instead of the Echo Lab because I didn't want to confuse everyone for the sake of having, you know, 2 extra buttons. But I decided that it just wasn't a good example. The reality is these things are big and intimidating. And if I tried to show you a small, simple thing, I'd just be underselling it. So I used a device that may be on the small side as these things go, but it's still the real thing. This was used to make actual television. The guy who sent it to me told me that's what he used it for. And the skills, such as they are, given I think the quality of my training video here, should still transfer. I'm not saying that after watching this, you could go get a job as a TD. I don't even think I could. And I don't know how much of this info applies anymore. Newer mixers definitely have completely new concepts in play. They have all sorts of wild shit. 3D transforms, image processing, internal video players, keyframe animations, and apparently multiple discrete program outputs from the same machines. You can mix 2 different versions of the same show simultaneously. That seems buck wild, but the example I've heard is if you want different on-screen graphics for a TV broadcast versus a live stream of the same performance, and that makes sense in this modern world of ours, but thinking about it makes me feel like my brain's melting. I don't think I could do it. But what I find remarkable is that when I first started looking into how broadcasting worked, I looked at all these pictures of TV control rooms, and I saw those monstrous control panels, and I thought, who on earth is smart enough to understand how to run that thing? And it turns out the really important features aren't that complicated. There's just a ton of them. For instance, the Grass Valley Cayenne, the mixer that was being used to broadcast the Super Bowl in the late 2010s, has a tremendous number of controls. I haven't counted. I think there might be over 1,000 on there. But that's because you can get those with up to 192 inputs. To pick any input for any purpose, every bus needs its own dedicated 192 keys, or at least, 40 keys and like 5 shift buttons, however they do it. But that's easy to understand, right? I mean, anyone could look at a monitor that says input 45 and press the key labeled 45. And there's more buses on there, I'll give you that, but that's not necessarily that involved either. Here's a better example. This is a big Sony switcher. There's literally hundreds of buttons on this thing. It's terrifying, but this set of keys does the same thing as this set, and this one, and this one, and this one. It's actually 4 mixers in one trench coat. They call each of these mix effect units, or MEs, and they're each basically a standalone mixer. You can use them to produce multiple outputs, like I was saying, or you could feed the output of one into an input on another. So you could take an image of a news reporter, put a lower third underneath with their name, and then put that into a box, use it as the input to a key, and fly that over the shoulder of an anchor. So you get, mixes within mixes. It's sort of like what tape-based music producers used to call bouncing, where you'd mix down several tracks, complete with effects, record them onto one track, and then use that as a source to continue layering more effects. Except TV is live, so you've got to do it all on the fly, and that means that each ME needs its own dedicated program and preset bus. It needs access to each input, plus all the MEs need extra inputs so they can select each other, and they each need their own cut and auto buttons and their own T-bar, and that's how you end up with this massive expanse of controls. But on a lot of productions, I'd guess most of those MEs just sit there doing nothing. They're just there if you need them. Ultimately, there's still a program bus somewhere on there that determines 95% of the picture that the viewers see. At least that's what I think. I've never used a mixer with more than one ME, and I don't know if I ever will, since nobody's ever sold one of any age for less than $5,000. And there are lots of other controls on new mixers that I don't understand, but in a lot of cases, even the more advanced ones are still mostly just a lot of little things. Like back on the Sony mixer, these buttons over here, those are for DSKs, downstream keyers. I want to explain the difference between upstream and downstream, maybe in some future video. There aren't that many controls for a DSK though. It's like 3 or 4 buttons, but there's just a bunch of them. This column does the same thing as this one and this one and this one. You got to learn how one works, but once you do, you automatically understand how they all work. So in just a minute or two, I've whittled down this landscape of incredibly complex controls to actually just a few that are simply replicated over and over. So it's not nearly as intimidating as it looks, and I think that's part of what fascinates me about digging into this stuff. 4 years ago, if I was out somewhere and I saw a camera operator from the local news, I'd look at their camera and think, good Lord, that's so many controls. How can someone remember what all that stuff does? But then I read a bunch of manuals and I got a couple old cameras and I learned what all those controls do. And now when I see one, it just makes sense to me. I'm not a skilled camera operator. There's more to it than just reading the book, but it's just neat to see something that seemed impossibly complicated and then turn it into something that makes sense to me, that seems normal and natural. Even if I could run a camera, I still don't think I could be a technical director. I have way too much indecisiveness. It is wild to me though that after just a couple of years of studying these things on and off, when I look at one of those gargantuan machines at ESPN or whatever, I think to myself, I could probably muddle through. It kind of makes me feel like I'm in the I know Kung Fu scene from The Matrix. And if I did a good job with this video, maybe you'll feel the same way now. If so, I'll have accomplished my basic goal, but there is a little bit of mopping up to do. First, you might be wondering if this has any audio features. No. In fact, as far as I know, pretty much no video mixer has anything to do with sound, with the exception of the ones that have built-in video players. I'm sure they have to output the sound somewhere, but typically video and audio are completely distinct disciplines, and if you think about it, that makes a lot of sense. We could imagine, for instance, a video mixer with, say, 8 inputs and 8 audio channels, and it could just tie them together, So when you press camera 1, it just enables the mic associated with camera 1. And those exist. The Grass Valley Indigo, for instance, offers exactly that feature, but it's just a little guy. It's clearly meant to be like a highly compact, portable gadget, probably intended for ad hoc environments, bands playing in the park, and that sort of thing. But in an actual studio setup, audio is rarely handled that way because TV just doesn't really work that way. If you're watching a game show, for instance, even if the camera is only showing one contestant, you can usually still hear everyone on set. They don't go away just because they're off screen. And when the news cuts back from the weatherman to the anchors, you can still hear both sides bantering. It's not to mention football, where you hear the combination of hundreds of mics being turned on and off to follow the action, so you always hear exactly what you need to get the full impact.
And Bucker is hooking and hits the post.
So you don't usually want sound to be coupled to the camera angle. You need it to be independent, and it's too much work for a TD to handle all on their own in addition to video. So there's usually a sound operator with a dedicated mixer board who handles all the audio on their own. Next subject. I mentioned that the data video mixer was missing too many essential controls, and that's just because it sucks. But I also mentioned that my Panasonic mixers weren't suitable for this video. And that's not because they're crappy, it's just because they're different. This is the Panasonic WJ-MX50. It's the first video mixer I ever got. It's always been one of my favorites for just kind of playing around. It looks impressive, but it's actually really low end. You can tell because it's got the 4-channel audio mixer built in. So this is intended for, I don't really know, little tiny productions. Churches, I guess, probably use the hell out of it. Churches have always been a big market for small video mixers, but it's also a lot of fun for making like funky video art stuff. It's got a whole bunch of buttons on here, all these silly effects. You know, it's stuff you'd never use for anything serious nowadays, but if you want to make like mid-80s MTV nonsense, it's got all the various corny wipes that you would expect for the era. But in addition, it also has a built-in keyer with edge effects. And you can either use that to, you know, mix two images, or you can just give it a matte like this. And there is some wild stuff you can do with this. What is even going on the screen at this point? How do I do this?
You have 3 Wolf Moon to chroma keyed yourself.
I have, but how does that work? It's great fun for playing around. It's just fantastic for video art. I can't really recommend a better mixer for just sort of trashing analog video. You should totally get one if you can. But when I tried to use this as an example for this video, I found out it didn't work at all the way I expected. And it turns out that's just because mixers used to work differently. Let me show you. This has 2 buses, but they're not labeled program and preset. They say A and B. So I've got camera 1 on the A bus, camera 2 on the B bus, and I can transition between them. That seems normal enough, right? But a few things aren't quite right. Notice the transition occurs on both displays at once, preview and program. And the inputs don't swap on the bus after I complete the transition. And I did a transition instead of a cut because this mixer has no cut button. Now this all mystified me until I complained about it online, and someone described this as an A-B mixer, a term I hadn't heard. Now looking that up online is pretty tough, but I stumbled across a manual for a modern mixer from Blackmagic Design, which actually offers A-B as an optional mode. And it gives some limited background. They imply that A-B is an archaic technique, which has been replaced by the modern method, which Blackmagic outright states is just plain superior, and I'm inclined to agree. See, with the A-B approach, there's no program bus. Whichever direction the T-bar is pushed is the program bus at any given moment. See, this light shows which one is actually live. That's the only way to switch between buses. If you want to do hard cuts instead of transitions, the only way to do it is by just hot punching them on whichever bus is currently active. And there's no cut button because the inputs don't swap. Whichever buttons you press stay right where they are, so there's no point in cutting. That also means that there's no preview bus, and there's therefore no automatic previews. Apparently, the ability to get a preview of what you're about to cut to before you cut to it was a novel feature at some point. They actually used to call it look-ahead preview. It's universal now, so they don't bother anymore. Now, this has a preview output, but I can't make heads or tails of it. I actually thought while I was writing the script that it had the option to attach the preview output to one of the 2 buses with this little control group up here, but it turns out that actually controls the program output. I have no idea how to use this thing. Ultimately, it seems like when you switch inputs on this, you just have to hot punch them and hope that you don't just flub it and hit the wrong button. It seems like a real mess. Now, I couldn't find any history of this stuff online, really, so I'm just gonna completely freestyle it and make it up. My guess is that A-B switching is how things worked back in the 30s and 40s when TV got started, because back then they had to use mechanical switches, pretty much like the ones in that game console switcher I showed you earlier. And this is really the only way those could work. You could absolutely build multiple input buses like this with that kind of radio button mechanism, and you could put a fader between them to do dissolves, but there's no real way to get the buses to swap after cuts or transitions. You know, you'd need the buttons to actually punch in and out on their own. In the 1940s, it would have been incredibly difficult to get the selected inputs to trade places. Now, by the 50s or 60s, that had certainly changed, but then you had a bunch of people already working in the field who were familiar with the old way of doing things, so I'm guessing it probably just stuck. In fact, I get the impression that for several decades, there was a big division between video switchers, which did nothing more than switching and possibly basic fades, and then devices that could perform wipes and keying and all the other stuff. I've noticed that a lot of the older mixers I find on eBay from the late 70s and 80s are actually labeled special effects generators. I've got one myself. It's this Panasonic guy, which I don't have a date on, doesn't have a year on it anywhere, and I can't find any info on it. I get the impression it's from the early 80s, but as you can see, it says special effects generator on it. And it's also more of a rack style unit than a desktop one. It seemed to be how it worked for a while. I've looked up a lot of these on eBay and it seems like they're all meant to go in racks for some reason. Now this is basically an entire video mixer, just like the one we have here, just using the older A/B switching method. And I think that over time, these started to drift towards the modern ME or mix effects method, which is the one I just spent this whole video explaining to you. I think that at one point, a mix effects unit was a distinct piece of equipment. This wouldn't have been the primary switcher in a studio. It was a special piece of equipment that not all studios had or used. You'd have a normal switcher and then you'd have this there for special purposes. But over time, as the technology got cheaper and special effects became more expected, the two devices, the switcher and the ME, merged into one. And of course, the ME style interface came with it. And then eventually people forgot that the distinction ever existed and just started calling them all mixers. And people forgot that the old A/B switching approach ever existed. So the moral of the story is, if you decide to buy a mixer, especially an older one, make sure you know whether it's A/B or ME ahead of time. Almost all new ones seem to be ME, but the older ones are a crapshoot. This does, however, raise the question, what relevance does this have to any of you? Do you need one of these? Short answer, no, you don't need one, unless you're just fascinated by TV production like me. Even if you're like a video artist, one of these is not even the best option. You're better off with one of the Panasonics. They're cheaper and they've got better funky effects. And of course, being from no later than the mid-2000s, none of my stuff does HD, including this. And as soon as you add HD to the mix, pun intended, prices skyrocket. I mean, they're already bad enough. For reasons I don't comprehend, standard def video gear just refuses to depreciate. This system is still $800 on eBay. Why? Who's buying them? I don't get it. Even the schools are HD now. I know, the people running the classes keep emailing me. So yeah, this stuff's all stupid expensive, and it's even worse if it's remotely modern. Really, if you need one of these, you'll already have one because your job bought it. They're capital expenditures, they're industrial gear. The only reason you'd want one casually would be for streaming, and you probably don't want it for that. Because yeah, as a lot of you with streaming experience have been thinking this whole time, yes, you can just use OBS or vMix instead. If you're wondering what makes the hardware worthwhile versus doing it all in software, the answer is nothing, as far as you and I are concerned. Now, let me get this out of the way. OBS, specifically, isn't a replacement for a video mixer. It's cool. I use it weekly. It's an incredible piece of software. It's fantastic for streaming, but that's what it's optimized for. Streamers who build ornate layouts with dozens of layers and then reuse them over and over. Video mixers, on the other hand, are all about managing multiple inputs, building simple scenes, and flying by the seat of your pants. OBS isn't really very good at making changes or building new scenes quickly. So if you just want a simple 2-box layout with 2 inputs and a background, you can do it on a mixer a lot quicker and in fewer steps. And actually switching inputs in OBS while maintaining the rest of a scene layout, even that is really awkward. vMix, on the other hand, is meant to be a software version of a video mixer, and while I've heard mixed opinions, pun again intended, it is almost certainly more than good enough for any amateur. If you just want to stream with like a 4-camera setup, you can buy 4 $50 webcams, pay $60 for vMix, and get something that'll not only work, but it'll be far more capable than a hardware mixer that costs twice as much. That's the point I'm making. A lot of the time when something that's been hardware for a long time suddenly becomes available as software, you get the same trade-off. The software does in fact offer a ton of features and flexibility that often aren't even in the hardware options. And a lot of the time it's for very low cost, and there's really no reason for the average person not to use it. The hardware remains relevant only to people who can't tolerate downtime, malfunctions, or computer bullshit. If your livelihood depends on shows going smoothly, you'll want something that's less likely to crash or to drop suddenly to 15 FPS out of the blue due to some obnoxious Windows update, and maybe even something with fixed input IDs instead of a bunch of USB gadgets that change identifiers every time you reboot. I know there are some people who use vMix professionally, but every time I've heard someone talk about it, they had some choice words about the experience. Amateurs, though, all seem perfectly happy. And with that, we're now actually done. I drug this video way out because I wanted to talk about context and underlying concepts, but if I just summarized the controls, this would have been over in 5 minutes, and most of you would have left sooner because who's here for a training session for a job they don't even have? I wouldn't watch that video. But thank you for watching this one. If you enjoyed it, please subscribe. That way I know that people like what I'm doing. Maybe turn on notifications too, so you find out when I upload new stuff. But if you really liked this, then consider supporting me on Patreon like these people are doing, because otherwise I will go flat broke from buying stuff with very little idea how to weave any of it into a narrative. Some of this crap I've had for 5 years, and I keep telling myself that someday I'll figure out how to show you all something novel with it. Hasn't happened yet, but we'll keep going as long as I can keep paying the bills, which all my patrons make possible. I can't thank all of them enough, but I'll thank the rest of you just for watching. Have a good one.